Thank you for inviting me to talk at this event. And so my name is Johan Kristiansson, and I'm going to talk about an open source project that I've been working on for a couple of years now. So a little bit about myself. I mean, I've been working in the academia as a researcher, and I also been having various positions in the industry. So I've been building several AI products, commercial AI products, and so when building AI products, you typically end up in a quite complex. You have to deal with quite complex IT environments, and so you want to deliver service rapidly to meet business demand. And in order to do so, you need to be sure that your services run 24/7. You need to have business continuity. And so everything needs to have, the whole stack needs to be high availability. If something crashes, another service should just migrate to another node and it should work. You need to have predictability, and if you run a workflow, you should get the same result. So the whole industry has migrated to something called containers to package software. And it's crucial to reduce all kind of manual interaction. So today's modern IT software, it heavily relies on automation tools. So actually, the whole IT environment, I mean, you can think about it, everything becomes code. So you can, using a configuration file, you can decide what kind of compute resource you want to have, and then it will automatically spin up. So that's called infrastructure as a code. And something called Kubernetes, if you have heard about that, that is everyone is using that for orchestrating containers to manage this kind of infrastructure. And as you can see, typically you don't have only one platform. You can have, sometimes you have many cloud environments. Sometimes you also have an on-prem. So you have this is called a hybrid environment. And fortunately, there is a huge landscape of hundreds of tools and frameworks that you can use to manage your infrastructure. This screenshot shows just a small fraction of the cloud-native foundation landscape. And there are tons of AI tools here that you can use for model distributed training, model serving. There is also something called AutoML, so you can automatically handle the whole training phase and deployment of models. So it's of course you have to, you can see this is quite complex, just knowing all of these frameworks, and you need to know a lot. It's a high learning curve. But then if you go to HPC, then you will find that, well, you have to use a login node. There is a login node you have to use, which means that you have to do everything manually from a terminal. You don't have this kind of predictability. If some other person log in and type command, you don't know what kind of state the system is. And typically this is even prevented because you cannot share accounts. So it's only one person, and you have to have multi-factor authentication to even log in. So there is no possibility to automation at all in this environment. And so when I coming from the cloud, I found this very awkward to have this kind of setup. But then again, I mean, this is not necessarily something bad, because Kubernetes have an extremely high learning curve. So I know people that they want to just run a notebook or something on Kubernetes, and it's super, super difficult for them to use Kubernetes. So actually, if you use something like Slurm, it's much easier to use than Kubernetes. And Kubernetes is not designed for HPC anyway. So you cannot run computational fluid dynamics, this kind of simulation, on a Kubernetes cluster efficiently. So in fact, I mean, if you want to run a scientific research workload, this environment is pretty optimal, actually, because it's more explorative in nature. You want to run something, and and then you want to, maybe you get some findings. You want to change your workflows. So why would you ever try to automate something and if you only want to run it once? Yes, so this is, so it's really difficult to say which kind of platform is better than the other. I mean, it's totally different. So on one side of the spectrum, you have cloud computing. It's designed for large-scale production system. There's tons of AI frameworks you can use, and it's you get access to a global infrastructure. And on the other side, this side, you have HPC, which is designed for research kind of workflows. You can solve complex engineering problems. You get access to a huge amount of hardware at the same time. And in the middle, you also have your own local environment, your laptop, maybe you have a GPU, gaming machines. So what I've been working on is an idea that you can kind of combine all these kind of environments into something called a continuum. And I'm not sure exactly how much I'm running out of time, so I have some slides. So I think I'll go a little bit ahead and talk about what actually is a continuum. I mean, if you maybe you heard about it, there is a lot of traction on this, especially from the European Commission. They are talking about a continuum and putting a lot of money into creating such an environment. And a continuum is it's an integrated collection of computational resources that are spanning devices. It can span environment and infrastructure, and you can access it from a unified interface. So instead of having disparate isolated technologies and systems, you get access to a coherent framework that you can use to write application. And you don't have to think about which kind of environment exactly you're using. So users, they will tap into this continuum, seamlessly tap into this continuum when they want to have computational resources. And I like to think that the ultimate vision of this technology is to make computation as pervasive as electricity. And this is not a new idea. There's something called utility computing. But I think this is something that goes beyond just cloud computing. It goes from IoT all the way into HPC. So think about how you use electricity in your home. You just take an appliance connected to an outlet, and it works. So if you want to need a heavy-duty washer, you can just borrow one and connect it, and you can use it, and you no longer need it, you can just return it. And this is, I think, how HPC should work in this AI accelerator. If you need an HPC, you have your continuum, and then you get access to a powerful HPC system, and you just plug it into your continuum, and then you can use it seamlessly. And then when you're done, you can switch to a cloud environment, and you can use that instead. But you see, how do you implement such a continuum? And then one way of doing is through a meta operating system. And a meta operating system is something that spans all this environment. So the whole idea is to have some kind of central management, and you have decentralized execution. So the idea by introducing a meta operating system is that you get something that is as easy to use as a cloud environment, but it's kind of distributed across devices, platforms, and infrastructure. And I think the whole purpose of this is to make it easier to use. You can integrate with other platforms to make this a unified experience, which I think is very important. And Colony OS is my kind of idea how this meta operating system can be implemented. So I've been working on this for 4 years, and I mean, it's designed to be resilient, scalable, and most importantly, easy to use. So I guess I might be running out of time. 2 minutes. So part of this concept is a colony, and a colony is a decentralized cloud, part of this continuum. And you have different executors that integrate with various kind of platforms, for example, HPC, Kubernetes, containers, IoT. And you can access all that from this colony server, which actually is a broker. So using this, you can write new kinds of application, and you can have this kind of plug-and-play kind of usage of computational resources. And part of this is security, and I could spend an hour just talking about how to implement security, because that's very important if you try to combine various platforms into this kind of continuum. It has to be the building, the foundation. So what do we do? This is actually working. We have been trying this on both Lumi and Leonardo, and it works on Kubernetes, Docker. So you can, there are tutorials, you can spin this off on your laptop. If you have a Linux or access to Docker, you can it takes just a command and you have set it up. And so what we can offer kind of help you to get access to a EuroHPC system, and then we can also help you, assist you how to connect that into your kind of continuum. So that was my last slide. Yeah.